to the Desk of Lady Ada.
Hey everybody, and welcome to Desk of Lady Ada. We have a new cam, so I'm closer to you. And tonight we're just going to do kind of a fast little video. I just thought this would be a useful tip for people who are doing electronics. This comes up a lot. I was booting up my Pi3, and I was having some difficulty with the serial console. And it turns out there's just a little bit of a bug in the serial console baud rate. But I was like, you know what, this happens so much. You know, you're connected to a board, you don't know what baud rate it is. And I thought I would just quickly show how you can use your oscilloscope, you know, or if you have a logic analyzer, use that. And some tips on how to get to weird baud rates if you have to connect to a device with a non-standard serial port. So, that's kind of what we're doing. I only got this working like 10 minutes ago, so I haven't really gotten to play with the Pi3, but it does boot, so that's cool. And that's kind of what we're gonna do tonight, and then maybe we'll do some more Pi3 hacking now that I've got it up and running. Okay,
so what do you want to go to first?
Let's go to the overhead. Let's go to the hover cam. Okay, so I got my Pi3, yay, we have a Pi3. I didn't have one before, and I have one now. And you got that nice big chip, and then you've got the RAM on the bottom. And I burned a copy of Jessie onto an 8 gig card. And the way I pretty much always connect to a Pi is to the console. I like going to the console because I don't have to worry about Wi-Fi being flaky or like pulling an Ethernet cord. Like, I can always do that, but I don't have an Ethernet hub here. So instead of pulling a cord from the other room, I like using the serial console. So I use a prolific-based serial console. These are very reliable and fairly low cost compared to FTDI or Cypress or Scilabs. And so another thing I like about these cables is they come with the power, ground, RX, and TX separated, so they're easy to connect. I'm not going to use the power line. I'm just going to use the serial pin lines, and then you can connect them to ground, TX, and RX on the Pi. They are in this order. And then you can go to your computer. So let's go to maybe quad view or computer view. Let's try computer view. You can go to your, you look up your device in the device manager. I've got COM78. And then, COM78. And then traditionally you do 115 kilobauds. So let's open this, and then you plug in the Pi, and you just get like this crazy non-normal text. Like, you can see that like there's data coming out, but it's not coming out in any reasonable baud rate. And like, this should be like the login prompt, but it's not. And I'm typing data and like nothing's coming in. So kind of weird, because all the other Raspberry Pis have always had a serial console at 115.2 kilobaud, but this one is off. Like, there could be a lot of reasons for it. It could be like, when they compiled it, they forgot to adjust for the frequency, or they didn't generate the clock for the UART properly. But I wanted to actually try to get this working through the serial console, even if it's a non-standard baud rate. And I also thought like this is a pretty good demonstration of a technique that you'll definitely need if you're reverse engineering electronics. This is like a really common thing. You have a device and you're probing around and you think there's a serial port, but you have to figure out what the baud rate is. So you can use something like a bus part or a Sele logic analyzer, but I don't have those hooked up. I only have my scope hooked up. So I thought I would show you how to do it with a scope. So let's go to maybe quad vision, because this is where I'm going to have to get to the scope as well. So what I'm going to do is, so I've got my scope, and then I'm going to bring this down here. Yeah, that's fine. So I've got my console cable, but I'm going to disconnect it. So disconnect these, and I'm going to connect my oscilloscope probe. So connect ground to the third pin, And then I always forget. Let me look up what the console cable is. Because it goes black and then white is into the USB port. So white is the output. So yeah, so I want to probe on the second line here. And you see from the oscilloscope that it's 3.3 volt logic, so that's correct, so that's good. It should be high. And then what I'm going to do is I'm actually going to reboot the Pi, and I will set the trigger mode to be falling. That's what you want for serial because it's logic high is idle. Mode, let's do normal mode so that it will trigger on the last byte. And then unplug the Pi, the voltage drops low. And then, so you see we have a baud rate, and then I'm just going to do a single capture. So I just did a single capture just to make it easy to measure the pulse width. Actually, yeah, I'll just do this. So you just try to get, and you might have to do a couple tries because again, the pulse width can vary. So you want to make sure you get it with the narrowest pulse, and then turn on your cursor, and then you want to measure time, and then you'll just measure either whatever is the shortest pulse high or pulse low. In this case, I'm going to be measuring this high pulse here. Try to get as close as possible, and then you can measure on your cursor that this is about 72 kilohertz, so that's 72 kilobaud. So yeah, that's not, it's supposed to be 115, but it isn't. And if you notice at the beginning there's some even higher frequency, so it could be like on boot there is some like a super high baud rate debug for the built-in BIOS. If you want, we can also check that out. I'm kind of curious, but just remember this is going to be 71.5 kilohertz. So let me unplug this, do another single sequence, and then see if I can capture that. So yeah, this is like some super high frequency, not super high, but fairly high frequency. And then, measure this as well. So this is giving me about 1.7 megahertz, so like a super high frequency. That sometimes like happens, especially with a device like this. You might have like the BIOS, the built-in like bootloader might run at a very high frequency. So because it would load firmware or something. So I've seen this once in a while, like very, very high baud rates. Not all chips can do such high or unusual baud rates, but and I'm assuming this is serial data. Look, it looks like serial data. I could hook up a logic analyzer to get this. Oscilloscope isn't so good at capturing this data and decoding it. But you can hook up a logic analyzer like the Sele, and it'll actually decode this data. It may even be able to figure out the baud rate. But anyways, so back to our computer. So now that we know the baud rate, we actually want to close this session, and hint, I already did this previously. We're gonna hold on, 1 second. We want to connect at 7200 baud. So COM78 at 7200, and then we'll also reboot this again. Oh, of course you have to connect the serial console cable. Don't forget to do that. And it's giving us other weird data, but it's not that's not really good text either. And so the question is like, well, did I like set the baud rate wrong or something? And like, yeah, there's definitely also data coming out here, but it's also not right. So this is where we're actually going to go back to, let's go back to the console cable, and let's just figure out like what are we actually outputting. Because that's also good. Like that's, by the way, like when you're debugging or reverse engineering, you can't assume anything. So let's figure out what baud rate we have. So I'm going to connect some jumper wires. And this time I'm connecting to the green wire because it's data out of the USB port. And connect my probe. And then we're going to go back to run, but we want to trigger. And when we type, actually, let's do, that's cool. So did I get the same result? I'm trying to remember. I know it didn't work, but I don't remember whether it didn't work in this way. Sometimes you'll get, yeah, no, it's actually not working. Okay, so it's actually not, like if I'm typing and I'm sending characters, it's actually not showing up at all on the scope. And you might be wondering, like, well, what did you, why, what's going on? Well, it turns out that the prolific chipset, the PL230X, which is inside this console cable, actually doesn't support weird baud rates. Like you can't do something like 7200 baud. You have to use a different chipset, like Scilabs can do it, or FTDI can do it. These are like more expensive, like higher quality chipsets. Again, it's rare that you'll need it, but I happen to always have an FTDI cable. Also, the FTDI cables can do those higher baud frequencies. I think the prolifics do tap out at like 230 kilobaud, whereas you can do much, much faster with FTDI and others. So I'm going to plug in this FTDI cable. And then if I connect to, got like a whole mess here. If I connect to the FTDI cable, so let's do that. And then, so now my scope is going to be connected to the FTDI cable, and I'm going to close this. Yeah. And then load this up, but instead of using the prolific, I'm going to use the COM33, which is the FTDI cable, and open this up. You can see I'm actually getting data out. And so if you want to verify that your baud rate is the baud rate you think it is, I actually suggest using a capital U, because it is a 10101010. So that gives you like a really easy way to get, hold on, let me trigger menu and then normal. That'll give you like a nice square wave. Makes it really easy to test. Sometimes multimeters, even if they have a frequency detect, and you send it capital U's, it will also detect the frequency. Is there a question or?
Well, there's some questions that are outside of this.
Okay.
So I don't know. Do you want to answer them? Or do you only want to answer questions about the thing you're talking about?
Well, how about I'll finish this up and then I'll answer any questions if they're not related.
That sounds good.
Okay, so I sent some capital U's over, and I'm measuring this pulse here, and I'm getting about basically 71.5 kilohertz. So that's cool. So this is very promising. So now I'm going to, now that I know that the baud rate is actually being generated properly from this FTDI cable, I'm going to wire this one up to the Pi. So I'm just using these little jumper cables who jumper from, this is why I like those prolific cables, because they have the cables separated. That's fine, I'll just hook this up. And then when I reboot my Pi, this time I actually get proper serial console data. So I ended up I spent a couple of minutes and figured this out, and then I went to GitHub, and turned out like 2 other people had submitted issues. So they know about this, and basically it's some clocking thing with the GPU versus the accessories. It's not a big deal, and I'm sure they'll figure it out, and I think there's even a firmware update, so there'll be a fix available for it. But I just felt like this is a really good opportunity to show people how to detect this stuff, because like everyone's like, oh, it's not working, but they didn't know what baud rate it was. And sometimes knowing what it is can help you determine what's wrong, because you're like, oh, it's exactly 1/2 or exactly double. You know, your crystal is off. You know, there's a divisor that can really be. Oh, hey, let's try this cat lens. That can really help you debug what's up, especially if you're doing something with a microcontroller and you don't know, you're expecting 115 kilobaud, but you're getting 57.6. You know that your divider is off by 2. So that can be like a handy trick to do. And I've been doing this forever, just debugging baud rates. And I remember, you know, if you get an ESP8266, they also have like a 72,000 BPS baud rate or something. It's an unusual baud rate that if you want to look at the boot messages, you'll need to like have, you know, something that can do that baud rate and check it out. So it's a good hacker trick. You know, having the right tools helps a lot. But every time I get a new platform, I seem to have to do this, because like there's often not very good documentation about, you know, or if they don't want to document the debug port, this is what you'll use to hack it. So next time you see a something with an RX and TX pad on it, hook up your scope and figure out the baud rate so you can connect to it with a console cable.
All right, you want to answer some questions?
Yeah, I'm going to shake a cat.
Okay, unrelated question. Will Adafruit carry Huzzah boards with MicroPython pre-flashed?
I'm willing to do so, yeah. I think that'd be interesting. The good news is it's very, very easy to flash firmware onto a Huzzah. Like, you know, the ow.
Well, I mean,
Sorry.
You kind of shook the cat.
I shook the cat. Well, no, he's just trying to climb on me. By the way, if I don't shake the cat, he also tries to climb on me. It's pretty easy to upload it, and it's still in development. So maybe when MicroPython is more solidified, I would check it out. But for now, you can just load it on yourself with, if you have a Feather board, has built-in uploading capability.
Okay, can someone use the H2O SIM on the phone of Feather?
H2O?
I guess it's the name of a company. We're not familiar with it.
I don't know what H2O is, but if it's a T-Mobile a virtual operator,
3G compatible, probably.
it has to be 2G, and basically if it works on T-Mobile in the US, it works, and if it's if you're in Europe, just make sure it's GSM compatible.
Okay, is there any way to figure this out without a scope? This is a related question.
You know, when I was younger and didn't have a scope, I used a multimeter, and I haven't done it in a while. But if your multimeter has I had a really good multimeter that's like no longer made. It was like a Meterman 87 or something. Anyways, it was a good multimeter, and it had frequency in, and I actually could get it to detect baud rates. This is before Arduino, where you would basically set your baud rate with like a divider on a PIC, and it just kind of sucked. So, you know, I'd always get it like off by 2 or something. So I could use that to kind of detect. I would send capital U's from my program and then hook up a multimeter, like in a loop. It would send capital U's, and I would be able to detect the frequency. But I haven't done that in such a long time because I have an oscilloscope.
Okay, and those are all the questions.
Yeah. Actually, what I should do is write a little Arduino program that all it does is like you probe it and it will tell you what baud rate it detects. That would be actually kind of useful. Like it would just measure the square wave and just say like, hey, detected this baud rate.
Oh, best way to etch, I think they mean PCB, is photoresist?
Yeah, photoresist is good. That'll get you the most
right.
precision. Yay. Okay.
Okay, that's everything.
That's
so,
all I got. I had like a really simple one. You know, this is as far as I got, because I was like I have Pi3, and you know, I logged in, and the only other thing I did is I did get, you know, Wi-Fi to connect, and I did verify that it has Bluetooth Low Energy on it, but I didn't actually get to do anything with Bluetooth Low Energy or Bluetooth. So I verified that there is a Blues device, but nothing to do with it yet. So that's a to do. But so far, so good. I got it booted. That's the most important. Any other questions?
No, that's
No?
everything.
Great.
So That's it. We're gonna continue to have Disc of Lady Ada. For the folks who want to know, if you're on GitHub, yes, just go on GitHub and look for Adafruit.
Yeah, we have like
It's,
500 repositories.
Yeah, I think we
It's
have.
not a good place for tech support. I'm noticing a lot more people trying to use it for tech support.
Yeah.
It's not a good place for tech support. It's good for like there is a bug in the library and I know what it is, or
Yeah,
I know it's a bug.
Also, for the person who wants to know the new products video, it comes out on Fridays.
Mm.
Okay.
Also watch it live.
And if you need updated Raspbian for Pi3, check out raspberrypi.org. They're the ones who run that.
You can use Noobs or Jesse. Actually, oddly enough, I'm almost positive that I downloaded a copy of Jesse and it didn't work, but then I just downloaded it again today and it did work. So I don't know how that happened, but I'm glad that it's working now. So yeah, it's working.
Okay.
I'll put my
All right,
jump
thanks
boots
everyone.
back.
We'll see you maybe Friday, maybe Saturday, maybe Sunday. We'll see. There's more Deaths of Lady Ada ahead. Thank you.
Oh yeah, much more.
Thank you very much, everyone. Don't forget, we are listener and viewer supported. We do this because people watch and because people pick up kids. Please go to adafruit.com and pick up some electronics. Any
Yay.
orders is what fuels this thing. So thank you so much for all the people who have ordered stuff, and thank you in advance for the people that are going to do that.
And thanks for people
Thanks.
watching this instead of the debate, which is good.
Yeah.
More learning. And yeah, we're
Yeah.
gonna have a lot more fun. Desk Lady, I'm getting back into the hacking
Yeah.
vibe.
We'll have these live from the Adafruit Factory 2. Stay
Yeah.
tuned. Subscribe to YouTube, and you'll see all of the new videos coming out as they happen.
Okay. Well, thanks for Thanks for watching, everybody. Have a great Thursday night.
All right. Bye-bye.